All right, I'm back to take a look at a couple more of these practice test questions. I'm going to run through three of them here. The first one I want to start with is problem number 22. Um, in this problem, it gives us a definition or an expression that represents x and an expression that represents y. The ultimate goal here is to figure out what x times y is equal to. So if I wanted to, I could take x times y. I'm simply going to substitute these values in. In for x, I'm going to take ab, or a to the power of b, and in for y, I'm going to take c to the power of b. So for x, I have a to the power of b, because that's what x is equal to, and in for y, I have c to the power of b, because that's what y is equal to. So really what we need to do is we need to figure out what expression from our options over here is equal to a to the b times c to the b. When I first did this test, my instinct was to look for this answer. Well, upon further investigation, we realized that that answer is not one of your choices. With exponents, we can think of this as the distributive property kind of backwards. It's probably not the technical phrase, but I think for our sake and for preparing for this test, that's the best way to look at this. Both of these values, a and c, have been raised to the same power. So what I'm going to do is I'm going to take that power out. I'll have a times c to the power of b. In a sense, as long as we're only multiplying in here, we can think of this exponent as affecting that and that. However, this is not true if this would be addition, so be very careful about that. If that was adding in there, this is where we would get to factoring and foiling to expand. But in this case, with multiplying, we could attach b to a and b to c. So our answer here in this particular example would be a times c to the power of b, which is h. The next one I want to look at is number 23. This is a question that was missed a lot, and I do think it's maybe one of the easier questions on the test. So just kind of a quick review here on combining like terms. The first thing I'm going to do here is I'm going to combine like terms within the parentheses. Inside parentheses, we can combine 6x with 12x, as well as a positive 2y with a negative 2y. Net positive 2y, negative 2y, including these signs help us see that these cancel out. 6x and 12x becomes 18x. So the expression we have after simplifying or combining like terms is 1/2 y squared, and inside parentheses we would still have 18x. 6 plus 12 is 18. I'm not sure if these parentheses confuse us. Remember that when we multiply, there's different ways of writing multiplication. We can assume that there's multiplication in here. We can assume there's multiplication in here. Or sometimes we'll just use parentheses to show multiplication as we have here. So really all of this stuff is being multiplied together. I think the most important thing to point out on this problem is that our powers on our variables need to stay the way they are. We can't combine y squared with x. They're different variables, they're different exponents. So the highest power of y we could possibly have is y to the power of 2. That allows me to eliminate this answer because we have y to the power of 3. It allows me to eliminate this answer because we have y to the power of 3. It allows me to eliminate this answer because we don't have y to the power of 2. So really the only options here would be a or c. Looking at this, we can multiply all of this together, and 1/2 of 18 is 9. Y squared x. Remember, multiplication can occur in any order, so we could have 9x y squared. The last problem I'm going to look at in this short segment is number 24. As I worked through this practice test before I signed it to this class, this was a question that probably took me more time than any other. And it wasn't until after the fact that I really took a step back and looked at what's the best way to do this. In the grand scheme of things, this is asking us to find the fewest paintings we can sell to make a profit of $60,000. This expression right here is my profit. So the profit we're going to make is going to equal 500 p minus p squared. And p doesn't represent profit. That might be part of the confusion. P represents the number of paintings we need to sell. So both of those would be represented by the number of paintings we need to sell. So our goal here is ultimately to make a profit equal to $60,000. Well, what we have to do, or the easiest way to do this, is to work backwards. We could pretty quickly see that if I sold 100 paintings, we would plug in 100 into paintings, and we would end up with 500 times 100 minus 100 squared. And by plugging 100 into there for P for paintings, 100 paintings, we would end up selling 100 paintings would give us a profit of $40,000. Well, the question wants to know how many or what's the least number of paintings we can sell to hit this value of $60,000. Now, in all reality, 40,000, a profit of 40,000 isn't too far from 60,000, so I would continue to check with 150 paintings. So rather than plugging in 100, we're going to plug in 150 for the number of paintings and evaluate that. So what we would have here is we'd have 500 times 150, and then we would subtract 150 squared. And by doing so, we end up with 52,500, which is also short of this ultimate goal of 60,000. However, you do notice that just by increasing 50 paintings, we did increase our profit by quite a large margin. So I'm going to go ahead and continue to check these. Working backwards, I'm going to check what happens if we sell 200 paintings. So we'll plug 200 in for P. Again, you would take 500 times 200, and you would subtract 200 squared. Doing so gives you 60,000. That's the profit, the minimum profit we're looking to make. So 200 paintings will give us an exact profit of $60,000. So the answer is, in this case, H. The important thing to remember is to work backwards. When in doubt, if you have a multiple choice test, it's always possible to work backwards. If I had plugged in 100 and got something that was a ways off of 60,000, it might be wise to jump up and try one of these higher values. But because I wasn't so far off, I just continued to progress through these options, working backwards until I had that profit of $60,000.